All right, good morning, scholars. It is, I don't know what day it is anymore, but today we are doing lesson 32-4, which is using the discriminant. So go ahead and take a second to pause the video here and write down your title and your objective. Okay. If you are back, I will assume you've already written down the part of the notes that I've got here, and you are ready to move forward with today's lesson. So first, let's give a quick reminder of what we did yesterday with Miss Babs. So yesterday she discussed how we use the quadratic formula. Okay, and if you remember, the quadratic formula simply looks like this. X is equal to negative b plus or minus the square root of b squared minus 4ac, all of that over 2 times a. Okay, so today we're going to be looking at just a small piece of the quadratic formula that we call the discriminant, and we use the discriminant to give us a couple of important pieces of information. So what I'm going to do here is I'm going to show you exactly what the discriminant is. It is just this piece right here that is found underneath the square root sign. So this b squared minus 4ac, that is the discriminant. Just a special name that we call it. And it's going to give us some interesting pieces of information that we'll look at in just a moment. So first, let's just make sure that we're comfortable calculating the discriminant. So let's give an example. This example will simply help you to find the discriminant given a quadratic equation. So let's take this example. So here is a quadratic equation, just like some of the ones that we've looked at with Miss Bab over the past couple of days. And just as a reminder, we can go ahead and label A, B, and C. So this would be A right here. This will be B. And it is going to be a positive 2, as we can see here. So A is equal to 2, B is equal to 2, and then C will be that negative 8. Once we have those numbers, we're going to go ahead and calculate the discriminant, which is just b squared minus 4ac. So again, I'm going to write the discriminant down here. B squared minus 4ac. This is what I'm trying to find. So all I need to do here is substitute the numbers up here into the letters down here. So if we look at what the value of b is, right here we said that b is equal to 2. So we'll go ahead and put a 2 right here where the b is. So that'll be 2 squared minus 4. Now we need to go ahead and put in our a and c. So what did we say that a was? We said that a is equal to 2. So I'll go ahead and put that there. And we said that c was going to be negative 8. All right. So now that we've done that, we just need to go ahead and continue simplifying. So what is 2 squared? That's simply 4. Okay. Over here we have negative 4 times 2 times negative 8. Okay. So what we can do here is say negative 4 times 2 times negative 8. We can plug that into the calculator, or you can plug that into an online calculator to see what you get. But it's going to be positive 64. Now you may say, okay, Ms. Cruiser, how can you tell the difference between if this is a negative 4 or if this is 2 squared minus 4? Okay, and let me just show you really quickly as a quick aside, because I get this question a lot, that they're actually the same. So look, 2 squared, let's say it's 2 squared minus 4 times 2 times negative 8. Okay, if we do this, we get a 4 minus, then we can do 4 times 2 times negative 8, which would give us negative 64, right? And then we know that this negative 1 right here, negative 1 times negative 64 is simply a positive 64, right? So even if we were to treat this sign right here as a minus 4 times 2 times negative 8, it's still going to end up with 4 plus 64, which is exactly what we got over here. Okay, so what is 4 plus 64? It's 68. Okay, so that's just an example of how to find the discriminant. Now quickly we're going to look at why does the discriminant matter, or what information does this give us? Okay, the next part's a little bit wordy, so I apologize. If we were in school, I would probably have been able to just go ahead and print this out for you guys. But I want you to go ahead and take a moment. Ooh, not all of that. Just this bottom part here, starting with the star, if the discriminant is positive. So I want you to go ahead and take a moment, and I'm going to read this through, and then I need you to write this down for me, okay? If the discriminant is positive, okay, so the example we just looked at, the discriminant was 68. Is that a positive number? Yes, okay? So if the discriminant is positive, like, here's some examples, 5, 36, or 75, as long as it's a positive number, the equation is going to have 2 real solutions and 2 x-intercepts, okay? So the info that the discriminant gives us is how many real solutions and how many x-intercepts. Now you may say, okay, fine. What is the difference? What do we mean by real solution? Is there such a thing as a fake solution? Like, what would that be? So we can have real solutions, and we have some things called imaginary solutions. And I know that sounds absolutely ridiculous, and we're going to talk about that in tomorrow's lesson, okay? So just don't worry about that for now, the difference between the real and the imaginary ones. And then x-intercepts, if you remember, we haven't done this in a while, but just take a minute. If you have a graph like this, the places where it touches our x-axis, right? This one's our x-axis. The places that our graph touches, those are the x-intercepts, okay? So those are the 2 pieces of information that finding the discriminant is going to give us. So again, looking up here, if the discriminant is positive, we get 2 real solutions and 2 x-intercepts. However, if the discriminant, if we calculate it, this b squared minus 4ac, and we get the number 0, like any of these, obviously all are 0, that means that the equation has 1 real solution and only 1 x-intercept. So that would mean it only would cross this graph 1 time. So for instance, that could look like, let me use that same color. That graph could look something like this, where it just touches, it just touches our x-axis in 1 point, okay? And then finally, what about if the discriminant is negative? If it's a negative number, like -3, -17, or -20, that will tell us that the equation has no real solutions and no x-intercepts. So that's a lot of words, and I'm just going to kind of condense that into bullet point form down here. I'm going to say, so if the discriminant is positive, if it's positive, that tells us that there are going to be 2 real solutions. Now, it doesn't tell us what those solutions are, does it? It just tells us that there will be 2 solutions that exist, okay? And it tells us that there will be 2 x-intercepts, meaning that the graph will cross, that's not how you spell that. The graph will cross the x-axis 2 times. Okay, continuing on, if it is negative, we will have 0 real solutions and 0 x-intercepts. Okay, and then the only other option, we could have a number that's positive, we could have a number that's negative, and the only other option would be if the number was 0. So if the discriminant is 0, that will give us the information that the equation will have one real solution and one x-intercept. Okay, we're almost done. I just want to give you guys a quick example of when we would use this and why we care about it. So I'm going to go ahead and flip my page. Okay, so the reason that we would ever use this or we would ever do anything with this, if you see a question that asks the following: how many real solutions does the following equation have? So if you get a question like this, what we will do is we'll say, okay, we'll look at the discriminant and see exactly what it's telling us. So here's the equation that we're asking about right here. So we're asked to figure out how many solutions does this problem have right here. It's not asking us what is the solution. It's asking us how many solutions will there be. Okay, so what we're going to do is we're going to go ahead and find the discriminant. That's going to be step one. And again, this is what we did in the first practice problem. The discriminant will be able to calculate using b squared minus 4ac. Okay? If we look up here, we can go ahead and label what a, b, and c are. Look at this negative right here. There's no number out in front of our variable, so we know it's a 1. This negative sign makes it a -1. So -1 is going to be a. Okay? -2, being really careful to keep that negative there, will be b. And -10 will be c. Now we can plug in. B is -2. So we have -2 squared. Again, make sure you put that -2 into parentheses or you're going to get the wrong answer in your calculator. Now we have -4 times A, which is -1, and C, which is -10. Okay, if we work this out, -2 squared is a +4. Okay, over here we have -4 times -1 times -10. That is going to give us -40. 4 minus 40, again, you can do this in your calculator or on an online calculator if you don't have one handy, is -36. So we found the discriminant. Now we need to see with step 2, what does it tell us? The discriminant is this a negative number, a positive number, or 0? Those are the only 3 options, okay? -36 is a negative number, obviously, because it has that negative sign. So we are simply going to look back over here and say, okay, if we're dealing with a negative number, what does that tell us? So that's this choice. If the discriminant is negative, oh, well, there's going to be 0 real solutions and 0 x-intercepts. So if we look back at the question asked us how many real solutions. And we just found out that because our discriminant is negative, there will be 0 real solutions. Ooh, I'll write it down here so you can see it better. 0 real solutions. And again, look back at what the problem asked us. It said how many real solutions. It didn't say solve for x, figure out what x is, blah, blah, blah. This right here is the answer that that question is looking for. Okay, so that is it for this video. Go ahead and make sure you do the practice problems, the do now, and the exit ticket, and send those in. If you have any questions, please feel free to reach out to me or Miss Bab. We will be happy to talk to you. I hope you're having a good day and stay safe and healthy. All right, see you tomorrow.